Welcome everyone. This is our first video in 2024, welcoming everyone with an enthusiasm of learning with us. First of all, I would like to thank Miss Lola Millie for answering our quiz in shorts. We are waiting for more response. We are continuing with our Python fundamentals operator part 2 and punctuator in this tutorial number 8. This video focuses on remaining operator, which helps us to understand binary numbers, bits, and those strings which are formed with the series of ones and zero that processor can understand. Additionally, we have covered the operator which helps us to find existence and matching of entities with another entities. And finally concluded this video with punctuator. Before starting with our tutorial, if you are new to our channel, please subscribe, and those who have already subscribed, please hit the like and share button. In our last tutorial, we have explained arithmetic, relational, logical, and assignment operator. Link is provided in the top right corner of this video. So without any delay, let's start with the bitwise membership and identity operator. Let's begin. Bitwise operator represent actions to be performed on each bits of an operand. We can see here on the screen the number 2 is also known as 0010 in binary, and 7 is known as 0111. So let's see how Python perform operations on bits with the help of bitwise operator. There are bitwise AND, OR, XOR, NOT, right shift and left shift operator, which helps us to perform operations on bits of an operand. Let's see. So let's see how bitwise operator works in Python. So here there is a truth table where we have got values as 0101 and 0011. So whenever we are performing AND operator operation with two operands whom having the bits as 00, the final result will be 0. And ahead 1 and 0, then 0, 0 and 1, then 0. Only both bits are 1 and 1, then we will get 1 as the result. So let's see this in Python shell. So here is our Python shell. We will try 3 and 4. And then when we press enter, we get 0 as an answer. So how does this 0 appears to be here as an answer? So let's see this with a graphic representation. So here is an example of that particular operation what we have performed earlier, like 3 and 4 gives us 0. So 3 is represented in binary 0011 and 4 is represented as 100. And when you perform AND operator or bitwise AND operation, like 1 and 0 will result into 0, 1 and 0 will again result into 0, and 0 and 1 will also result into 0, because we have seen the truth table. If there were 1 and 1, then we would have got 1 as an answer in the resultant bit. But all bits are 0, so final answer is 0. So we have now bitwise OR operator. Again, here there is a truth table where we have got bits, and when the bits are having 00 as a value, and when we applied OR operator, we get 0. But when we see any of the bits in the both operands, if it is 1, then we will get 1 as an answer in the OR operator. So here on Python shell, we will perform an operation 3 or 4. Then we will get 7 as an answer. Now, how does this 7 appear to be an answer? We will see it again with the graphic representation. So here we can see the example of bitwise OR operator. The same 3 or 4 gives us 7. So we can see 3 is represented as 0, 1, 1 and 4 is represented as 1, 0, 0. So when we perform OR operation between them, so 1 and 0 gives us 1, 1 and 0 gives us 1 and 0 and 1 gives us 1. If here there would be a case where 0 or 0 was there, then we would have got 0 in the result. But all bits are 1. This means it is the 7. Answer is the 7. Here is the working of bitwise XOR operator. In XOR, there is one unique thing. If both bits are same, the answer will be 0. And if any alternate bits are there in them, then the answer would be 1. So here you can see 0 and 0 gives us 0. Even 1 and 1 gives us 0. But 1 and 0 and 0 and 1 would gives us 1 and 1. Let's see this example on Python shell. So we'll take same example 3 XOR 4. We get again 7 as an answer. So here you can see example of bitwise XOR where 3 or XOR 4 gives us 7. Again, we can see 3 is represented as 0, 1, 1. 4 is represented as 1, 0, 0. So all are alternate bits in 3 and 4. So the resultant answer will be 7 like 1, 1, 1. Now we will see bitwise NOT operator where there is a number given and the negation of that number will be like minus of n plus 1. This is the shortcut to remember the output of NOT operator. So you can see NOT of 5 is minus 6, that is 5 plus 1 is 6 and entire thing become minus. Again, NOT of 32 is minus 33. Same goes for negative numbers. If you have NOT of minus 4, then the answer would be 3. See the output on the Python shell. So this not means it is tilde character. So this is how it gives the answer. So we have seen all the operation over here on Python shell. Now there are interesting operator, right shift and left shift. Let's see them. So bitwise right shift operator perform operation on one operand where it shifts the number of bits which is given over here like this. So when you use like 20 right shift 2, so it will shift bits inside the number 20 by 2-bit position ahead towards the right side. So let's see over here what happens when we do 20 right shift by 2 bits. So we would be expecting some answer. So let's see, the answer is 5 over here. Now, how does this 5 appears to be an answer? We'll drill down within graphical representation exam. So here we can see the example of bitwise right shift operator where 20 right shift by 2 bits gives an output as 5. So here you can look at the things on the screen where this top part is the decimal number, like the bit are arranged in this pattern like 1, 2, 4, 8, 16, and below are the bits that are represented in binary form. So if you would look over here, 20. 20 will be represented as sum of 16 and 4. So those below those number there are 1 and all others are 0. So here you can look like when you do in 20, 2 bits shifted ahead by 2 in the right side. This is how things goes. Here it shifted by 1 bit. So the blanks which are created on the left sides are filled with 0. So the bits are shifted from 16 to 8 and 4 to 1. Again, the bits are shifted by one more time because we have given 2-bit shift. So from 8 it shifted to 1 and from 2 it shifted to 1 in the right side, and the blanks which are created on the left side are filled with 0. So the answer 5 have came with the following operation one by one. Now in the series of bitwise we have got last, that is left shift operator. Similarly, like right shift operator, we have left shift operator where bits are moved towards left by the number we have specified in the expression. So here if we say A left shifted by 2 bits, then 2 bits are going to be shifted towards left in A. So we'll see it on Python shell. So here we will take example as 5 left shifted by 2 bits. So we got 20 as an answer. Now how this 20 has been formed, we will see with the graphical example. Here we have considered the example 5 left shifted by 2 bits. So we got 20 as an answer. We can again see the same thing, like we have got 5. So 4 plus 1 gives us 5. So below 4 and 1 there are 1 1. So 1 0 1 0 0. And then left shift operation has been performed by first bit, that is 1 bit shifted to the position of 2 and 4 is shifted to the 8 and the total is 10. Again, one more time the shift operation has been performed and then the bit 2 is moved to 4 and bit 8 is moved to 16. So the blanks which are created towards right are filled with 0 and we got final answer as 20. So everyone, I would like to say about left shift and right shift that whenever you perform right shift, the value is coming by division. Like you have seen 20 left shifted towards 2 bits, then the answer is 5. So 20 divided by 4 gives us 5. And same thing when it comes for left shift. So 5 when left shifted by 2 bits, it gives us 20, like 5 into 4. So 1 bit has got value as 2. So if you write 2, the multiplication factor will be 4. Hope you have understood about bitwise operator. So moving ahead with the next in the series of operators are membership operator. Now membership operators are those which helps us to find existence of any entity in a collection. So there are in and not in. Those are the operator which is going to perform the test, and after we get the test performed, we will get answer as Boolean value. So we are on the Python shell where we are testing membership operator in and not in. So let's define one variable as hello world and another variable as a tuple. And now what is a tuple? Tuple is the collection of any numbers within the parenthesis. So this is how it has been formed. Now we will perform the test with the help of membership operator. So if we write like this, print h in x. So what would you expect the answer will be? It will be false because uppercase H is not existing in hello world. So if you rewrite the same phrase, print small letters hello in X will gives us true. Same thing, we'll check it for a number test. If we say print 6 in Y, so this will gives us false. But print 2 in Y gives us true. Same thing is there for not in. If you write print 8 not in Y, so this will gives us true as an answer because 8 is not existing. So it checks the opposite of in. Okay. So we are at the topic of identity operator. This is the last operator in the collection of all operators in Python. So identity operator helps us to match any entity with another. So it is like giving an identity of one value to another value. So there are like is and is not. So we'll check it on Python shell. So for testing identity operator, we will define some variable like x1 is equal to 5 and y1 is equal to 5, 5.0. Okay. And x2 is equal to y2 is equal to, now we will test the is operator. So x1 is y1. So what would you be expecting? It is false because x is 5 and y is 5.0. So the type of both operator is different. One is integer and another one is float. But when you write print x1 is not y1, then we will get answer as true because they are not equal. Similarly, it is like for x2, if we go x2 is y2, we got false. But when you write print low is x2, we will get true as an answer. So this is all about operators in Python. So without any delay, we are moving to another topic known as punctuator. Now punctuators in Pythons are used to organize things like structure, statements, expression. We will be looking to them one by one. So they are like brackets, braces, parenthesis, comma, colon, semicolon, and many more are there. But for basic, we can focus on these 6 things. So let's see them on the Python shell. So the use of brackets. So brackets are square bracket. So whenever we declare a list in Python, it will always be declared within the brackets. So if you say list of numbers is equal to, so here is the first punctuator. So this list has been defined. The identifier name is list no. So we can see the type of list no is what? It's the list. Then we have got braces. So curly braces are always used to represent a dictionary in Python. So like student data. Now dictionary is a key value pair. So we would like to give name as we will have to use name. So comma which. So this is how it has been created. Now we will see the type of std data. It would be dict, that is dictionary. Now we'll go ahead and declare one tuple. So tuple is one where we use parentheses. So you can say weekdays, like Monday, Tuesday, Wednesday, and so on. We'll declare only three of them. Now we will see the type of weekday, that is a tuple. So this is how the first three punctuators are used: square bracket, braces, and parentheses. Now, comma. The role of comma is quite different. It is used to separate between literals, like if you are defining a value a, comma, b, comma, c is equal to 1, comma, 2, comma, and last one you will write alto. So this is how the three variables has been declared with the three different set of values. So comma is used like this. So we'll just print all the values a, comma, b, comma, c. So you can see the variable a has got value 1, b has got value 2, and c has got value alto. And we'll move ahead with the colon. So colon are usually used to define the body of the structures. So like if we are giving if condition and then body. So like here we can write if a is greater equal to 1, then print a is greater than greater or equal to 1. So this test has got passed because a value is 1. So we have put the operator as greater and equal. And last but not the least, we have got semicolon, where we can have the use of semicolon is like we can use it as a delimiter. And here in Python, we can write quite 3-4 line programs in one line with the help of semicolon. So just have a look over here. I'm defining a variable a is equal to 5, then semicolon. I'm writing print a into 2 twice of a, then again semicolon, print a divided by 2 or 2, and lastly we will use print a exponent 2. So we'll see all the result like this. So this is like we have used 4 line of program in one line. So first initialization of the variable a, then usage is like printing double of its value, half of its value, and squaring of a value. So to revise, we have started with bitwise operator. Bitwise operator has got AND, OR, XOR, NOT, right shift, left shift. All are working with the bits on those operands. Then we have seen membership operator to find the existence of one entity in a collection. So we have seen several example on Python shell. Then we have seen identity operator where it shows us the matching of one entity with another entity. We have seen all this with the live examples. Then we came up to the punctuator where we have seen how different punctuators are used in Python like bracket, braces, parenthesis, comma, colon, semicolon, all within live hands-on example. So everyone, hope you would have liked the explanation, content, and the topic. We would be very grateful if we have your suggestions, feedbacks, and comments. Thank you for watching with us. Do like, share, and subscribe. Stay tuned for more videos.